In this video, we'll finish up our discussion of section 11.5 with distance between a line and a point. So, drew a picture here, my line being the red line on the bottom, the point being the black point at the top, P. And then I drew a few things. The distance that we want to find is always perpendicular distance. So we want to find the green dotted line. I labeled it with a capital D there. I picked another point on the line. So we picked Q, just some random point on the line. I can take that point now, and I have a vector U, and I have a vector V there. And then I also have the angle between those two vectors, theta. So I can actually just use trig here. If we're looking for capital D, that is a sine, right? So sine of theta is D over the magnitude of U, not U. Remember, use a vector. I can't use it as a number. So that means that D is equal to the magnitude of U times sine of theta. So as long as I have the angle between, I can find it. So let's write that down and start working on that, because maybe we can come up with a better formula where we don't have to have the angle. So D is the magnitude of U times sine theta. Now, I'm going to multiply both sides. I know this is going to feel a bit strange, but multiply both sides by the magnitude of V. All right. Hopefully that right side looks familiar to you. That is the part of the definition for a cross product. Magnitude of a cross product is the same thing as, and I'm going to do U first, doesn't matter, but U cross V. The sign goes away because that's all that's equal to that, which means that the distance between a point on a line and a line and a point would be the magnitude of the cross product divided by the magnitude of vector V. Now, V is the direction of the line, while U is the vector from point on the line to the point we're trying to find. All right, so this can be a bit, quite a bit. So, okay, so we have, find the distance between a point. So we have some line and we have a point. So looking at this example here, I have some point off that line. Let me draw a better line. All right, I have that point. I need another point on the line. Well, I can pull a point from that line from the top parts, right? That always gives me a point on the line, -2, 1, -3. So I have a point on the line now. Cool. Now what was the next thing that we needed to do? Is we needed to come up with a vector that runs from that point to the point off the line. Okay. So, we shouldn't call this P because the other point was called P. Let's call it Q. Okay, so I can find the vector PQ. That vector is -3, 3, -6. That's just subtracting. Hopefully, if you can't do that at this point, you got some refreshing to do before you take this exam. So I have that vector. Cool. Okay, so we have accomplished, I think they called this U. We have U. Now, we want to find V, which is just some vector on the line. Well, what would work with that is our directional vector of our line, which is our bottom numbers there. So the directional vector here is 3, 1, 2. That is my directional vector. Okay, so if I want the distance, I need the magnitude of the cross product. So I need to find a cross product. All right, the magnitude, I'll set this up for us, and then I'll give us our answer, and you can do the work and make sure that you can do it. Just saving some video time. That's 2, I, J, K. All right, we got hats to show that they're unit vectors, and this works out to be 12I minus 12J minus 12K. Okay, so we have that. Now we would just find the magnitude of that. I trust that you can do that. So I'm going to write down my formula here. U cross V, and then divided by the magnitude of V. Okay, the magnitude of that, if you work that out, you get 12 root 3. I would check that. Take your magnitude of U cross V. And then the magnitude of V is just the square root of 14. If you rationalize this, you get 6 squared of 42 over 7. You don't have to ever rationalize with me. You can leave it. Right here would be an appropriate answer for me, as long as you just get down to numbers. All right, that covers all of section 11.5. It is pretty long. You're probably feeling that way now after doing it. I feel that way after recording all these videos. There's a lot going on here. I would make really good notes. The big thing for me, the common mistake that happens after all my years of doing this, the common mistake, and I actually made it at one point in this video. You won't see it because I took it out. But sometimes the big mistake I make is I will take a plane. I'll see an equation of a plane. I'll think it's a line. I don't know why I do that. And I've said it a few times trying to get you not to make that mistake. Keep in mind that you cannot write the equation of a line in 3 space. It's either symmetric equations or parametric equations. You'll never get a single equation well, I guess the symmetric is a line of equations, but you'll never get one equality for all of your line.